All right, welcome back. I am Dr. Boyd, the chemist, and we have today another live experiment that we'll be doing. And today's experiment is raining raining colors. And you'll need water, you'll need vegetable oil, not a lot of vegetable oil, maybe 2 to 4 tablespoons at the most. Like that might be too much. Food coloring, and again, I know a lot of people don't have food coloring, but if you do, you can follow along with this one. You'll need water-based food coloring. If you have gel-based food coloring, it won't work as well. All right, and then you're gonna need 2 separate cups. All right, so that's what you'll need for today, and we will get started in about 2 minutes. Hey, Anita. Good to see you. Hope you're doing well. All right, we're going to go ahead and get started with today's lesson. Again, I'm Dr. Boyd, the chemist, and I am a research chemist at the Naval Research Lab in Washington, D.C. I am teleworking, so I have a limited amount of time each day that I can do this, but I hope I am helping the parents and the students who are unexpectedly learning from home these days. All right, so today's lesson is called Raining Colors. And again, you're going to need water, you're going to need vegetable oil, you'll need food coloring, water-based food coloring, and you're going to need 2 cups. This is interesting because everyone's at home. We're like doing things we typically wouldn't do. Like I would normally go to the barber and have the barber fade me up. I noticed on one side I should have faded it in person. It looks blended pretty well, but on camera it don't look as good. The other side looks maybe a little better. I'll get it right next time. All right. So, oh, I see the Wilsons are in the house. Good to see you. A couple folks over there on Instagram. All right. Well, today's lesson actually combines 2 concepts that we've dealt with in the past few weeks. You may recall I wrote it down in my notebook, and hopefully you have your notebook. Lessons 14, we did a density tower. And then lesson 19, we did a lava lamp. All right. Lesson 14 was in week 3. Lesson 19 was in week 4. And in both of those, we dealt with the concept of fluid density. Fluid density. So I'll write that down because we will be dealing again today with fluid density. And again, you should have your notebook because you want to write down what what we're working on. You want to write down why. You want to write down the questions we have to answer, and we want to write down our hypothesis. And do you recall what a hypothesis is? What is a hypothesis? All right, a hypothesis is an idea you can test or a guess you can test. All right, so lessons 14 and 19, that was the density tower and the lava lamp. We dealt with the concept of fluid density. Fluid density. All right. Then lesson 15 and lesson 23. Again, weeks 3 and 4, we dealt with in lesson 15, making a cloud in a jar. So we made a cloud inside of a jar. And then lesson 23, the lesson was called Make It Rain. We actually made raindrops in a jar. All right. Now we're going to combine, those seem like very different concepts. We're going to combine those two today with our lesson entitled Raining Color. All right. So we're going to have rain in a cup. But before we do that, what is the most important thing for a scientist to pay attention to whenever they do an experiment or run a reaction? What is the most important thing? If I go into a laboratory and I don't even intend to run a reaction myself, but somebody else may be in the lab, what's most important for me to pay attention to? Safety. Safety is the most important thing to pay attention to, no matter if I'm the one doing the reaction or someone else is, okay? And in order to be safe, typical things that I wear when I go to the laboratory include eye protection, normally goggles or safety glasses. I wear covering for my hand, gloves. I get the right kind of glove too. And I wear a lab coat to protect my body, protect my clothes. All right, so these are the things that we do in order to stay safe. And that's really just basics. There are other things that we would do too. Like if I have really long hair, I wouldn't want my hair everywhere. So I would tie it up because it can get caught in some instrumentation or maybe fall into my reaction. If I have jewelry on, right, like a watch that hangs down or a necklace, I want to take those things off because I don't want them getting caught on some of the equipment. All right, lots of really bad injuries have been caused because people didn't pay attention even to those types of things. All right, so safety is most important. Fortunately today, like most of our lessons, we don't need to wear goggles, we don't need to wear gloves, and we don't need a lab coat because we're only dealing with vegetable oil and water in a glass with some food coloring, okay? So we don't need those things today, but I do want you every time you do a reaction to think about safety, all right? And Chris, good to see you. And Uncle Joe, good to see you. All right, well, what are we going to do today? We're going to reinforce the concept that water and oil do not mix. Not only do they not mix, but they have different densities. Okay, they have different densities. So we've been over this a couple of times, but I will ask the question. You can write this down in your notebook, and then you can write down an answer that I hope you're able to answer at this point if you've been following these lessons. If I take water and pour it into a cup, and I take oil and pour it into the same cup, what happens? Do they mix? Does water sit on top of the oil? Does oil sit on top of the water? All right, what happens if I pour oil and water into the same container? Will they form one uniform layer or will they separate out? If they separate, which one is on the top? All right, I'll give you about 10 seconds to think about that. Which one's on the top if they separate? All right, well, if you're paying attention to the density tower and to the lava lamp, you'll recall that water is going to go to the bottom and the oil is going to go to the top. They have different densities. They also have different molecular makeup that contributes to this effect. But without getting into that aspect of it, water has a greater density than vegetable oil or cooking oil. All right, so that means that the cooking oil will be on top of the water. Also, they do not mix, and there is a much more complex explanation as to why they don't mix, but I'll just let you know they don't mix, and that the oil layer will be completely oil, all sitting on top of a water layer that is completely water. You're not going to find the oil just in the water and staying there indefinitely. If the oil is in the water, it will eventually separate out and join its buddies in the oil layer. Similarly, if there's water encapsulated by oil, it will be in the oil layer for a moment, but it's going to eventually drop down to where its buddies are in the water layer. And you're going to have a solid layer of water underneath a solid layer of oil. All right. So for today's experiment, here's what we shall do. I have a cup here. I am going to take a little bit of oil. Again, I think maybe 2 tablespoons should do it. You don't want to use too much oil here. I'm going to take 2 tablespoons of oil. I'm going to eyeball it. You might want to be a little more precise and actually measure it out with a tablespoon. I'm going to go get some water and place it in a separate container. And I'm going to fill this up about halfway or maybe 2/3 of the way. I'll do it 2/3 of the way so you all can hopefully see. And I do hope that the cameras pick up what's going to occur. Pardon me. Okay. Now, I have water, I have oil, and here goes the fun part. I am now going to take some food coloring. And I got all these colors here. Again, I happen to just have a lot of this stuff because I do these types of things at schools frequently. So I am going to take 3 drops of each of these colors. I've got blue, yellow, green, and red. And I'm going to take just 3 drops and put it in the oil. Now, my food coloring is water-based food coloring. So before I do this, I'm going to ask a question. Let me just explain. When I say water-based, what that means is that this dye, this food coloring dye, is very concentrated dye in water. All right, so it is a dye that is in water and it's very concentrated. What I mean by concentrated is that only 1 drop will make a lot of water turn blue, for example, or red or green or yellow. Okay, so here's my question. It's water-based. Can I mix this water-based food coloring in the oil? All right, think about that for a moment. Remember what I said at the beginning of our lesson today about oil and water and what happens when I put them in the same container. All right, so here we go. I'm going to take 3 drops of each of these colors and put them in the oil in this container here. All right, and if you're doing this at home, you should see something pretty cool when you drop the food coloring in. I don't know if you're able to see it with my cameras here, but this is yellow. Oh, of course, I got food coloring on my fingers, and I feel like blue is the worst one to get on your hands because it's hard to come off. All right, last one is red. Of course, I got blue all over my fingers now. Okay. I will try to move this to the camera so hopefully you can see it. Let me wipe some of this blue food coloring off my hand, which will probably take like 2 days to get completely up no matter how many times I wash my hands. Look what happened. You see that? So all that food coloring, all it did was it stayed separated from the oil. Hopefully my people there on Instagram can see that as well. All right. So I've got these balls of water-based food coloring inside of oil. Now, I asked the question, can I mix it in with the oil? So I forgot to mention you may need you'll need something to stir with. I've got my fancy glass stirring rod here. I'm going to stir this up and we'll see what happens. right. Look what happened. All right, so it appears that the water-based food coloring did in fact mix with the oil. Do you believe that? All right. Now, what I want you to do, if you're following along at home, I have my container with water in it. I've got this other container here that had all this food coloring. And what I'm gonna do, my food coloring and oil mixture over here, is I'm gonna pour it into the water. And let's see what happens. All right. Well, actually, before I do that, let me ask you, what do you think is gonna happen? I just took some food coloring, water-based food coloring, and stirred it up with my stirring rod in this oil. And I started the lesson by telling you that oil and water don't mix, that the oil will separate out from the water and vice versa. That's what I said, right? And when I put the food coloring drops in, you saw there were little balls of water-based food coloring at the bottom of the oil, separate from the oil. But then I stirred it and it looks like they all blended together. So when I take this now and I place it in the water, what's gonna happen? What's gonna happen? All right, get ready for a really cool show. I hope you're able to see this well. Oh, sorry, I forgot the other part here. Got ahead of myself. I really want to see this. Remember when I explained how the water cycle works? So we were talking about rain. This was lesson 23, and it was an extension of lesson 15, where we made a cloud in a jar. And I said that there is a water cycle, and the water cycle works like this. The sun heats the earth. That includes all the bodies of water, lakes, rivers, streams, oceans, seas. All right. Then, as it heats all those bodies of water, the water evaporates. It goes up into the atmosphere. And that first step of the water cycle is called evaporation. Once it gets high enough, the air is cold, so it condenses. So the second step is condensation. The water condenses. When it condenses, this is the part about making a cloud, that water that's now water droplets or ice crystals in the upper atmosphere mixes with dust in the atmosphere. That makes clouds. Again, go back to lesson 15 to see that happen. Once we make a cloud, it gets bigger and bigger and bigger and bigger as more and more moisture and dust get together in the same area. And then at a certain point, the cloud gets so heavy with moisture that something else happens. This third step of the water cycle process. So we have evaporation, we get condensation, and then we get precipitation. All right. So the water is so heavy inside the cloud that it begins to fall from the cloud back to the earth. And then the cycle repeats as that water that went back into the bodies of water on earth get heated up again and go back up into the atmosphere. All right. Well, today we're going to see something very similar. I'll make a relationship. I'll explain the relationship in a moment. Now we can do this experiment now that I've set the stage for that. I'm going to take my oil that has been mixed with water-based food coloring. I'll mix it up a little more. All right. It looks really hideous. Looks like a really dark mixture of some goo. And here we go. Get ready for the show. All right. Look what happened. The oil went up to the top. Now keep watching. Behind this so everybody can see really well. There it goes. Look at the show. All right. What do you think is happening right now? What do you think is occurring? If you have an idea, write it in your notebook. What do you think is occurring right now? All right, now keep in mind, when I said I was combining two concepts in explaining this, we talked quite a bit about the difference in density between water and oil. But the concept of clouds being so heavy that the moisture eventually drops out of the clouds. Well, we're seeing something very similar here. The food coloring that I stirred in with the oil does not mix with the oil, not permanently at least. It appeared to mix temporarily. What's happening now is that food coloring was water based. It is separating out from the oil at the very top and going to where it's happier, and that is inside of the water. All right, so this is very much likened unto the heaviness of water in a cloud getting too heavy and eventually dropping down to earth. In this case, the more dense water that was in the food coloring gets so heavy that not so heavy, but it's happier and it's more dense, obviously, than the oil. Is going to be happier going into this layer of water, or this large layer of water. All right, I probably should have used more brighter colors. It would have looked a lot prettier. So if you do this right, I would recommend using red and probably yellow, and you could probably just leave it at that. What ends up happening is you have this layer of really dark food coloring and oil at the top, and then you'll see all these red streaks and these yellow streaks drop down into what was once the clear water. All right. So if I let this sit for, let's say, an hour, what do you think you'll see? All right. Remember when we made our lava lamps? I had a big layer of oil and I had another layer of water at the bottom with red food coloring in it. Well, you're going to see something very similar. If you allow this to sit long enough, what happens is all the food coloring that is water-based at the top that was in the oil will drop down into the water layer, and you'll be left with a very yellow oil layer at the top and this dark water layer at the bottom. They will ultimately, the water-based food coloring will ultimately completely separate out from the oil. All right? That is our demo for today. But let's briefly review. If I take oil and I place it in the same container with water, what happens? Will the oil separate out from the water and form two separate layers? Will the two layers mix together? All right, if they separate out, which layer will go on top? Water on top or oil on top? All right, hopefully you know. Now, this is the third lesson that deals with this concept. So the water will be at the bottom, the oil will be at the top. The density of water is much greater than the density of oil, so it will sink down to the bottom and oil will be at the top. Okay? And briefly, what are the three major steps of the water cycle? What are the three major steps of the water cycle? We get heat from the sun that causes water to evaporate. That's evaporation. All right. As the water evaporates and gets into the upper atmosphere, it gets pretty cold, so it condenses. That's called condensation. It forms water droplets and ice crystals if it's cold enough. Those water droplets, they get combined with dust in the atmosphere and they form clouds. And ultimately, those clouds get bigger and bigger and bigger and bigger. And sometimes they get so heavy with moisture that they drop all that moisture to the planet in the form of water, rain, or snow. That's called precipitation. And then the cycle starts all over again. So we have evaporation, condensation, and precipitation. All right. Okay, so that is our lesson for today. I will see you back here again tomorrow, 2:00 p.m. Eastern time. If you want to look at the lessons that I referred to earlier today, you can do that by going to my YouTube channel. Go to YouTube, search for Dr. Boyd the Chemist, and in fact, you can subscribe to the channel and you'll get all the updates. Obviously, I'm posting all of these lessons underneath the title Homeschool Science Lessons. Homeschool Science Lessons. I have organized them into the weeks. So week 1, week 2, week 3, week 4, week 5. This week is actually week 6. And once I'm done with this week, I'll post that as well. The lessons that I referred to today are lesson 14, that's density tower, and lesson 19, that's the lava lamp. Those deal with the concept of fluid densities. Also, lesson 15, that was cloud in a jar, and lesson 23, that was make it rain. Those deal with the water cycle and the making of clouds and what happens to water as it goes through the water cycle. All right, with that, thank you. I will see you tomorrow. Goodbye.